Hi, Assalamualaikum everyone. My name is Muhammad Azizi bin Sarmidi and I'm the team leader for my group. We are from UPNM and these are my group members for this project. Our project title is IoT car parking system model. So for the background of this project, firstly this project is IoT based and model based. IoT car parking system model or STLK IoT stands for Sistem Tempat Letak Kereta IoT is the combination of software and hardware installation to develop this project. This project is called as IoT because the software, hardware, and smart devices need to be linked and connected together with the internet. Actually, the idea of developing this project is born after I seeing one of the building in the UPNM always has parking issue due to the limited of parking space. So after that, I meet up with my group members. We discuss about this problem. We then finally come out with the car parking concept to invent the project in order to assist the staff at the building to find their car parking effortlessly without wasting their time. After a big discussion with my group members, we found the only way to develop this project is to put the IoT characteristic into this project. And please don't get me wrong, as I said, this is the model concept and IoT based because when this project is invented and developed, the issue happening at the building of the UPNM is not totally solved. But this is the first step to invent the new and advanced car parking system for our industry and for our country as well. I will show to you and tell to you that we were using the hardware, which is plastic board, toy car, the electronic stuff, and the most important thing to develop this project is the IoT board or non-MCU. The smart devices that I mentioned just now is referred to the any smart devices that can access to the browser. So the quick example that I can say is a smartphone. The problem statement for this project has three. The first one is take long times to find the car park. Second is still using traditional way to find the parking. And the last one or the third is people is worried about the current status of the car parking, whether it's fully occupied or not. The objective for this project that we have to achieve are the first one, to suggest the new car parking system to find the car park faster and easier. Second one, to develop online car parking system. And the third one is to apply the IoT characteristic, which is sensor, sensitivity, connectivity, and intelligence into this project. So actually, these objectives have answered and solved the problem statement, especially for the third point. People or staff will not worry about the current status of the car parking as they can put the trust into the system, and most of the time, IoT systems are always accurate and functional properly. Now, let's go to the methodology part. This project, we use agile model as our methodology. The advantage of using agile model is really accurate and suitable with the development concept for this project, as it capable to respond to any changes of environment, plans, or anything related for this project system. Fast forward to the discovery part. So how we discover and explore to invent and develop this STLK IoT? Actually, by many resources such as the interview session, discussion among group members, observation site, and of course, internet research. And after all these resources that we find, we discover and we explore, finally, we found a way to develop STLK IoT. So the way is, we must have sensor, connectivity, intelligence, and the other IoT characteristic to put into this project. So after that, we come out with the connectivity between these hardware devices. Resistor, LED, light depending resistor, and the most important is non-MCU. All of this hardware will be instructed by non-MCU, as we have to upload and burn the coding to instruct them into the MCU, which we were using the C++ as the language. Resistor, LED, and LDR are instructed by non-MCU, and all of this hardware are integrated with the software. The software I mean is the user interface. So for the user interface, we were using JavaScript, HTML, CSS, and PHP. So the benefit and the contribution to the society of this project is, first, save their time. Secondly, able to find car park easily and faster. The third one is society or people don't need to worry anymore, as they can access to the car parking system to view the parking status through their smartphone. And now let's go. We jump to the project demonstration. So as you can see here, there are two versions of our circuit or our hardware installation. The left one is the smaller version that act as the prototype. The right one is our actual version of the project and hardware installation. The prototype left here, actually we want to make sure that all connection, all the installation of the hardware is function properly according what we have programmed them and burn it into the non-MCU board. After we ensure that all this hardware are function as planned, we then transform them or transfer into the actual version like you guys can see at the right picture. There are 8 pairs of LDR and LED which represent 8 parking lots. Non-MCU was connected to the computer by using a cable, and this is how we burn and upload the coding, the C++ language from the computer into the non-MCU board by using Arduino software. Now we rewind back whenever me and my team was in the process develop the prototype for this project. So the concept here is LDR is act as a light detector and will give the value of the light that it detects at the current time. So when the LDR detects low lights, it will generate a decreased value, and when the decreased value generated, the light indicator at the user interface will become red, which means the car parking is occupied. So right now, I try to limit the light detected by LDR and see that generate a low value. As you guys can see. So after the hardware installation function properly as programmed, we then connect the prototype into the actual user interface of this project to make sure all the setup will work properly. The software, by the way, we develop it using HTML, CSS, and PHP for the database, and then we connect the software and the hardware by using JavaScript. As you can see there, the value A until H are the values that we obtain from the LDR, like dependent resistance, which give us the light values at the current time. When I press stop, that means the LDR, all the LDR will stop function for a while, and when I press start again, the LDR will continue to read the light. The LED, by the way, is the indicator to show that LDR is functioning properly. When LDR emits the light, means that the LDR is capturing and reading the light. And now, this is the actual version of the project developed, which after we have done with the hardware installation, setup, trial and error, done with the prototype, and this is the UI, the actual UI for the project that having connect with the board and all. So when I put the hand on the LDR, I want to limit the light so the LDR will detect the low light. Actually, I need to do by putting the toy car, this toy car, on the LDR to make sure that the user interface, the parking lot become red. But it's actually the same, the light still read and capture low light. About the connectivity to the internet, I launched XAMPP so that my laptop can act as a local host. To view this user interface, I open browser, Microsoft Edge, with 5 icons from the left on the taskbar. Right after that, I key in the IP address which address to my local host, and thus, there you go. As I mentioned earlier of this video, STLK IoT is just a model concept and can be commercialized. This project is more likely as an indicator to visualize the concept on how we can enhance the car parking system technology. So, to commercialize this project to become a real development for us, we can use load sensor. Program the load sensor to detect the object's load that more than 1,000 kilograms, and then the indicator light will turn red. So the driver or the staff will acknowledge and know that the parking lot is occupied and not available for that moment. Other than that, we can also use proximity sensor that able to detect the presence of the object without any physical contact. We also have magnetic sensor. Magnetic field will be affected because it has been generated by magnetic sensor. Magnetic sensor will detect a conductor which will affect the magnetic field value. So this will affect the current flows and current values in the microcontroller. So in this scenario, the conductor is a car that parked in a parking lot. After all this happened, we can program all this electronic stuff in circuit so that the indicator light on the user interface will turn red, which give the message to the user that the parking lot is occupied and not available for that moment. So to detect the presence of the car accurately, we might need a multiple sensor for one parking lot. We then can program it and customize it, all the sensor, all this electronic stuff in the circuit that can match with the site requirement by using microcontroller. And also, thank you judges and panels for your attention and concern. My team and I are really glad and happy for this opportunity. Until next time, bye-bye.